So in example 4, ladies and gentlemen, it says a student is mixing cobalt nitrate, okay, and it's cobalt 2. So I've got cobalt, nitrate has a charge of -1, and cobalt has a charge of 2 plus. When I drop and swap, the 2 goes here and the 1 goes here. Now, that is aqueous because it's a solution, and it gave me a volume of that. So I immediately know it's a solution. I am reacting that with excess sodium hydrate. Guys, excess just means there's enough of it, okay? It's not gonna matter. That's also aqueous. Now, what type of reaction is this? If I have 2 ionic compounds, 2 aqueous solutions, I've got a metal, a non-metal, metal, non-metal. When we switch them, we call this double replacement, DR. So that means the metals are going to switch, and I'm going to get sodium nitrate, which if you check your solubility tables is soluble, and I'm going to get cobalt hydroxide, which is a solid. How do I know that? Okay, I check my solubility table, I go to OH, I go down, cobalt is not there, so it is insoluble. Now, if I just look at my question, let's just write down the given information, okay, before we even look at anything. So it's told me that the volume of cobalt nitrate is 225 milliliters. I know I don't like milliliters, so let's put that in liters, okay? Again, I don't know what the question's asking. I'm just writing down the given information. The concentration is 0.078 moles per liter, okay? Well, whenever you have volume and concentration, guess what? You can always calculate the moles. So let's just do that. Again, don't even know what the question's asking, but you know, we can do something. Liters cancels. Okay. You're going to get 0.01755 moles. Okay. Now, let's just think. Whenever you have a balanced chemical equation and moles, you can use the molar coaster. Now, I jumped a little bit ahead. I forgot to balance that initial equation. So if you did that, good job. If you haven't done that, let's do it right now. All I need to do, guys, is say, okay, there are 2 nitrates right here, 1 here, put a 2 here. 2 sodiums, 1 sodium, 2 OHs, 2 OHs, good. Now, remember, I need a balanced chemical equation and 1 mole value of 1 chemical to ride the molar coaster. The molar coaster tells us that we can use some information of 1 chemical to find out information about another chemical. If I read the question, it says predict, which means calculate, the mass of the precipitate. Precipitate means solid, so this is my precipitate. I want the mass of this precipitate. I remember from mass stoichiometry that mass is moles times molar mass. Can I find the molar mass of that? Yup, periodic table. Can I find the moles? You bet. Molar coaster. So let's do that right now. I divide by where I start, 1, and I multiply by where I'm going, 1. That was pretty easy. So the moles of cobalt nitrate is the same, 0.01755. The molar mass of cobalt hydroxide is, look in your data booklets for cobalt, 58.93 plus 2 oxygens, so 16 plus 16, plus 2 hydrogens, 1.01 plus 1.01, we get 92.95 grams per mole. I've got moles, molar mass, boom, I can find mass. I get 1.63, 12 ... grams. I need 3 sig digs, I believe, yep, 1.63 grams. That's how much I'm going to produce. So if I do this experiment and I collect all of the solid, all of the precipitate, and I measure it in the lab, I'm going to get that much. So again, guys, if you noticed, the procedure of how we ride the molar coaster is identical every time. The only difference in these questions, guys, is figuring out the moles. We either use solution stoichiometry or mass stoichiometry, and the last one's gas, which is just the ideal gas law. All you need, balanced chemical equation, enough information to find the moles, boom, molar coaster, and you're done. But like, as a scientist, this is extremely cool because you are now able to say, all right, if I have these two chemicals, I'm going to produce this. So in grade 10, you balanced it. In grade 11, you're saying, not only can I balance it, but I can tell you if I use this much of one reactant, I will guarantee that I'm going to get that much product. And that is a really cool thing.